Hi, 8th grade. All right, go ahead and open up your books and go to page number 9. We're going to do lesson 2. Okay, so what we're doing in lesson 2 is we're understanding rigid transformations and their different properties. So they have some rules they have to follow. They can't just be like, oh, look, it slid. We have to actually look into it and find out how did it slide? How far did it slide? How can I make it slide again and be the exact same type of transformation? Let's go ahead and look at number 1. Try these two problems involving the rigid transformations over here. Figure PQRSTU, which is the pink one, is a transformation of figure ABCDEF. Okay, what that means is that ABCDEF was the original picture, was the original image, okay? So the transformation is now pink, which makes sense because ABCDEF comes before PQRSTU in the alphabet, right? Okay. Is figure PQRSTU, is that a translation, a reflection, or a rotation? And explain why you think so. Okay, so if you looked at it, give it enough time to look at it, you can pause the video, really think about this. Does it look like I have a point that pivoted the figure? Remember in basketball, if you put your foot down, you can pivot. Does it look like any of my points were the point where it pivoted? If that was true, your corners would still be touching, and none of the corners are really touching. So I'm going to say it's definitely not a rotation, because it didn't really rotate or pivot. A translation, remember a translation just means a slide. Does it look like the figure just slid over to that new pink space? No, because if it just slid over, it would look like this. Right? That would be a slide. So their only option is a reflection. And if you look, you can even find exactly what the line of reflection was. The line of reflection is right there. And I know that because exactly B and Q are one space away. C and R are exactly one space away from the line of reflection. D is 1, 2, 3 spaces away. S is 1, 2, 3. So their corresponding sides match up, which is perfect for a reflection. So our answer is a reflection. Now it says to explain your reasoning. I could say, if you flip figure ABCDEF across the line of reflection, we would get PQRSTU. If you flip figure A, B, C, D, E, F, across the line of reflection, you get, oh gosh, what is it? PQRSTU. Okay, long explanation, but it makes sense. Okay, I'm gonna go ahead and erase my little doodlies over here, because the next question says, draw an arrow to show how figure ABCDEF moved, and add the center of rotation for a rotation or the center of reflection for a reflection. So we do know that it flipped, right? It didn't rotate, so we can ignore the rotation part of that. I'm going to go ahead and just draw right here my line of reflection, and then I'm going to show you that it went like this. It flipped over the line of reflection. So go ahead and draw that for me. Draw the dotted line to show the line of reflection, and then go ahead and draw the arrow to show that it flipped over. Okay. Remember, if I go too fast, you can always pause this. Number 2. When figures are the same shape, You can identify the corresponding parts. Remember, I've been saying that word every now and then, corresponding, between the figures. Angles in the same relative position are called corresponding angles, and sides are called corresponding sides. When you name figures that are the same shape using a vertex label, it is important to use corresponding vertices in the same order. Let's look back up at these two figures. Figure PQRSTU is the image of ABCDEF. Identify the corresponding sides. Okay, so for example, side or line AB corresponds to what side up here? AB is the same as QP. But we don't say QP because P comes first in the alphabet. So I'm going to say PQ. Don't forget to put a line over it. Okay. How about EF? EF is the same as TU. Something and RS. Let's see. RS is the same as DC. I'm going to say CD though, because C comes first in the alphabet. Something and UP. UP. Ooh, be careful. Don't say BC. They're not the same lengths. How about AF? Okay, BC. Let's see here. BC is the same as QR. All right, and then what? And ST. Let's see, here's ST. With that little guy. Oh, there he is. DE. Perfect. Do you see how corresponding sides have like a side that's the exact same length as each other? They're just flipped, right? How do the lengths of corresponding sides compare? How do you know? Well, they're the same length, right? The lengths are the same. You can use that grid to compare the length by counting how many little boxes it is, right? So we're going to make this answer super easy. We're going to say the lengths are the same. Okay, the lengths are the same. And how do you know? Because you can count them. 1, 2, 3, 4, 1, 2, 3, 4. Okay. In figure ABCDEF, AB is parallel to FE. Now hold up. Let's go look at this. AB is parallel to FE. Yeah, it definitely is. They can extend and never touch. You can write this using the parallel line notation. Ooh, do you see it? It's so cute. Parallel lines. Right there. AB is parallel to FE. In figure PQRSTU, is PQ parallel to UT? Let's see. PQ and UT. Are those two lines parallel? Yes. And how can you tell? Because you can extend them and they will never, ever, ever, ever touch. They're the same distance apart forever. Okay. D. Look at the other pairs of parallel sides in figures A, B, C, D, E, F. What do you notice about the corresponding pairs of sides in PQRSTU? Okay, so let's see here. What do I notice? I'm going to go ahead and erase some of my stuff up here, just so you guys can see this better. But take a look at this. When we're talking about parallel sides, right? How about PU? PU and QR are parallel. If PU and QR are parallel, what does that mean about the other shape over here? It means that BC and AF would be parallel, right? ED is parallel with all of them as well, and TS. All of those green lines that I just drew, they're all parallel with one another because they're all equally spaced out and they will never ever touch if you extend them forever and ever and ever and ever and ever and ever and ever and ever. They'll never ever ever touch. Okay, so the question said, look at the other pairs of parallel sides. What do you notice about the corresponding pairs? Basically what it's saying is, if I can have a whole bunch of parallel lines on this shape, could I still have a bunch of parallel lines on this shape? And yes, of course. You guys, it's the same shape, it just got transformed to a new spot. So we're going to say the corresponding pairs of sides are also parallel. Oops, I'm getting out ahead of myself. The corresponding pairs of sides are also parallel. Okay. Ta-da! Next page. Page 10. Number 3. Ooh, there's a lot of figures going on in here. It looks like they're all the same shape, but they've all been transformed to something different. Oh boy, bear with me. We'll do this as organized as possible. Figure ABCYE, which is right here, ABCYE, that figure, HIJKL, and PQRST, all the pink shapes, okay? Let me go ahead and erase my markings. So all the pink shapes, that's what they just said right there. The pink shapes are images. Images, remember this for a second, okay? Images of the figure VWXYZ. So blue shape is our original shape. Pink shapes are the image. So what an image means is the image is like the copies. Okay, it's the new shapes, the new locations. So when I say look at the image, I'm saying look at the new copy. Okay? The original shape in this case is the blue shape. I want you guys to identify each of the pink shapes. Are they a translation, which is a slide, a reflection, or a rotation? Okay, so let's go ahead and start with A, B, C, Y, E. What is that one? So if I was here on the blue and I want to go to this shape right here, how did I do it? Did I slide it across? No. Did I flip it across a line of reflection? No. When they're all hugged up on each other like that, it's a real good clue that it got rotated. Okay? Just like in basketball, he's pivoting. And I can see where he's pivoting. What point do they share? They don't share X. See where X is right here? That's a point on the blue figure, but not on the pink figure. They do share Y, however. Y is a point on the pink figure, and it's a point on the blue figure. You can now see that what they did is they pivoted on their little foot, which is Y, and they pivoted clockwise. So now V would land where A is, Z would land where E is, and W would land where B is. Okay? So the very first pink figure, let me go and get rid of all my markings over here. Let me go and erase it. The first figure is a rotation. It rotated, it pivoted on its little foot. Okay, the next one. HIJKL. Okay. Now don't look at pink figure to pink figure. Ignore this pink figure. He's bye-bye now, okay? We're done with him. Look at blue figure to this figure. How did he, blue guy, get all the way over to here? What happened? Did he slide over? Did he flip over? Or did he turn over? Well, he definitely didn't flip over because they're not mirror images of each other. They're exactly in the same position. Like if I was standing at H, I'd still be at the top, like V, right? So I believe those are, it's a slide. But we don't call it a slide because we're big kids now. We call it a translation. So it translated. Translation. All right, and then our last one is PQRST. PQRST. Now remember, we're not looking at this one. We're not looking at this one. We're just looking at blue figure to this figure. Now, did it slide over there? No, because look, if it slid, here's what it would look like. Let me go and erase some things real quick and draw some things real quick. So what I'm doing right now is I'm tracing the original figure, and then I'm going to slide it for you. Here's what a slide looks like. Okay, they don't match up at all. That's not a slide. And that's obviously why we said that our answer for this one was a slide. Do you see how that one just slides all nicely? Woohoo! So the only other option we have left is it was a reflection. It's like a mirror. And I can very easily see the line of reflection. Can you guys see it? Right there. I know that's the line of reflection because do you see how from here to here is one point or one spacing? From here to here is one spacing. They'd all have to be equally spaced out, okay? That's how you can make a new shape, an image, super easily with a grid paper. Okay, so let me go ahead and put PQRST. It is a reflection. Okay, good job. Now, number 4 wants us to go find some corresponding angles, which is so fun. However, I kind of made a mess over here, so I'm going to clean it up for a second. Much better. Okay, remember, corresponding means like after it got moved, now what's its new angle's name? But it's still the same angle, really, same angle measurement. So, let's look. Angle V and what? Oh, sorry, we better read the directions. We're looking at this image, VWXUT. So PQRST. Okay, so it looks like we're looking at the reflection. So we're looking at these two right here, not the rest, okay? So just the one that got reflected. Angle V. Who's corresponding angle to angle V? Angle P. If I flipped it, whoosh, they'd land right on top of each other. Okay, angle P. Okay, how about angle X? Angle X, if I flipped it, whoosh, land right there. Oh, you know what? I think I'm wrong. It would not land on S, it'd land on R. Yeah, that looks a lot better. Gotta be super careful. Don't do what I just did. Make a silly mistake. Which angle and angle S? So let's look at S. Oh, S is what I just did. S and Y. Yep, those are corresponding. Okay, we got angle Q, the inside guy, and W. And then we got Z, and our very last one, T. Perfect. How do the measures of those corresponding angles compare? Like, for example, if I said the measurement of P was 20, angle P is 20, how do you know what the angle of V would be? Well, yeah, V would be 20 as well because they're corresponding angles. So corresponding angles always have the same measurements. That's going to be our answer. Okay, corresponding angles always have the same measurements. We're almost done. Okay, number 5. Look at the two modelets. The two modelets. Oh, I guess this is one modelet and this is another modelet. Okay, on the other side. Oh yes, here's the other modelet. Okay, so look at these two modelets. What we just did. How can corresponding sides and angles help you determine that the original figure in the image are the same size and shape? Well, that's easy. If I know that corresponding sides and angles are the same, then that means I can easily determine if the rotation or the flip or the translation is still the same image. So to make that easy to write, I can say figures have the same corresponding side lengths and angle measures, and you can verify that by literally just measuring it or counting, okay? Corresponding angles and sides are the same measurements and I can prove it by, oops, that says my. By counting and measuring. Super easy. Number 6. Transform this figure, JKLMN, to make an image, so like a copy, ABCDE. Draw and label the figure ABCDE and identify the transformation you used. Then use corresponding parts to show the figure and image that they are the same size. So they're not telling you what kind of transformation you should do. You could do a reflection, you can do a rotation, you could do a translation, whatever you want. I think I'm going to do a slide, which is a translation. If you want to try something different, go for it. I'm just going to do that just because that's what I feel like doing right now. So let's say I want to slide this whole figure by that's too easy, by 4 points. When I say I want to translate this figure 4 points, what that means is I'm going to take every single point, so I have J, K, L, M, N, and I'm going to move it 4 points. And I'm going to say 4 points to the right. So I want to move each of those points 4 spaces to the right. Ready? Let's start with K. 1, 2, 3, 4. So I'm going to go ahead and erase my jumps because I don't want to make a mess. But I now have K. K's new spot. Okay, now let's do J. 1, 2, 3, 4. Ooh, J lands on K. That's interesting. I'm going to erase my jumps so that I don't have a mess going on. Okay, I'm going to move L. 1, 2, 3, 4. Erase my jumps. M. 1, 2, 3, 4. And N. 1, 2, 3, 4. And erase my jumps. Okay, so now I have translated all my points. Now I just need to connect the dots. All right, so now I have my new image, And I need to make sure my angles all correspond. So do you see how the very first one they gave us was J, and then the first one they gave us was A? That means wherever I put my new J, it's got to be called an A now. So my new A is right here. My K is now my B. My L is now my C. My M is now my D. And then my N is my E. Ta-da! All right, so that is called a translation or a slide. We call it a translation though because we're big kids. And I gave it the rule it had to move 4 points to the right. You have to give your translation a rule because if you don't, then you could just literally move it wherever you wanted, right? So my translation moved 4 points to the right, and there are the corresponding angles. All right. That is all for today, and as you can see, when you turn the page, it is your homework. Don't forget, you can always go back to the video and rewatch it if it helps you with your homework. But I think you guys are going to do great. Translations, transformations, they're so much fun. So good luck. Don't forget to upload your homework onto this Google Doc so that I can make sure you get a grade for it. All right, bye guys.